Two.
Yes. Yes, I'm here. Just a second. So, Dr. Tim Mackey works with us here at the Native Biodata Consortium, um, along with Kaolu Fox at the University of California, San Diego. He's a professor of global health and the Global Health Program at UC San Diego, the director of Global Health Policy, and the Data Institute. He's the editor-in-chief of JMIR Infodemiology. He's also the CEO and co-founder of data science and research services company S3 Research. He holds a BA in political science, international relations, a master's degree in health policy and law, and also earned his PhD in global public health from the joint doctoral program at the UC San Diego. And with that, I am happy to hand it over to Dr. Mackey.
Hi, everyone. Can you guys hear me? Can you give me a thumbs up if you can hear me? Awesome. So I think just like Joe, a lot of us are under the weather. I unfortunately am recovering from an upper respiratory infection. It's not COVID, but probably got it from the kids, 10 and 12-year-old at home. But my voice is a little messed up, but I hope I can give you some information about a project that we've really passionate about, been really fortunate to work with Joe and NBDC on, and that's something we call BIDS, which is a blockchain to enable Indigenous data sovereignty. So I'm going to go ahead and share my screen. I hope we can have an interactive discussion, especially, as I probably take a few breaks here in between just to get my voice back. So feel free to ask questions at any time. I'm going to keep the chat open just in case I see any questions come in through the chat, or go ahead and just interrupt me anytime during the presentation. So first, thanks to Joe and everyone at IAI already and Bridge to AI for the invitation to present our project that focuses on leveraging blockchain to enable indigenous data sovereignty, specific to genomic data and specific to the context of the Native Biodata Consortium, NBDC. This is a collaboration with UC San Diego, the Indigenous Futures Institute, which Kaolu is a part of, and then, of course, NBDC as a partner, a community partner. And it's funded by the Robert Woods Johnson Foundation through what's called their Pioneer Portfolio. So I'm going to just give a quick background into the inception of this blockchain IDS type of tool that we're generating. Talk a lot about, the first phase of this project, which was focused on community engagement and understanding how blockchain can be used for data management, and not just specific to genomic data, but specific to Indigenous data. And then we'll talk about the actual blockchain architecture development and where we're going with it. We're kind of about 2 years into the project. So we're really working on the first prototype of this blockchain environment that we hope to provide on a GitHub repository where people can download it and then continue to iterate on it and hopefully implement it into data management principles. And then we'll talk a little bit about next steps for this project and what we hope to do with further collaboration. So I'll start with Kaolu Fox. He's the reason why we are embarking on this project, because we both have an interest in innovative and disruptive technology. Blockchain being one of those technologies that has been has had a lot of ups and downs. Frankly, I've been working in the blockchain space for about 7 years now, so that seems like a long time in blockchain. And I've seen multiple iterations of blockchain, what we call the initial coin offering phase, where companies were creating blockchain solutions and minting their own coins, and people were buying them to invest in them, and there wasn't much oversight of those companies. So we had this big kind of boom of blockchain, and then it disappeared. And then we also had a second boom when it was NFTs. So if you don't know what an NFT is, it's a non-fungible token, and these were things that people were creating with art and other things to essentially monetize different types of blockchain assets. And so that was a big boom as well, and it arguably has also dissipated quite a lot. And then, of course, the recent fraud-related aspects associated with some of the fintech companies and some of the exchanges has really put a damper into future blockchain development. But what we wanted to do, me and Kale, is to really focus on the good of blockchain and identify how that as a tool can be used for data management specific to Indigenous data sovereignty. And I know that all of you know what Indigenous data sovereignty is, so I won't have to, repeat that here. But essentially, we want to make sure that these systems are built from the ground up so that they reflect community values, and it's hard coded into the software and the code associated with this blockchain solution. So just as a quick history about this, we started off conceptualizing this about, I think it's about 6 years ago. And there's a lot of different use cases for blockchain that people don't really think about. So most people think about blockchain in the context of tokens or cryptocurrency, which is the leading application for blockchain technology. And in fact, blockchain technology was developed so that Bitcoin couldn't be spent in more than one place at more than one time, what we call the double spend issue. And that's what's really personified what blockchain is, but it can do so much more than cryptocurrency. So a lot of what I focus on is what's called business blockchains or private blockchains, where it's simply a data architecture to manage the flow of data, the provenance of data, and build more trust within digital communities. So the first iteration of this project was actually funded by a company called Luna DNA. And Luna DNA was originally an offshoot of Illumina. Most of you already know who Illumina is, the largest sequencing company in the world. And this was a part of a project that they wanted to spin off, where they wanted to create a more community-based data repository system. So the general principle behind Luna DNA was that people would donate information or donate data to a biodata repository, and in exchange, they would get shares in a company that was a public benefit corporation. This is a very unique kind of legal entity, and essentially you would be paid out equity related to the shares you had in the company. So it gave more ownership to individuals when it came to giving data to a company or a nonprofit or a public benefit corporation. And it was a new model to generate a more community-based data governance system. Now, we got our first project with them, which was called a hybrid off-chain blockchain system, where we wanted to identify ways that we could have data on the chain and data off the chain. I won't get into too much of that in the relation to this project, but essentially this was the prototyping we did because we structured this project around different forms of data. One being personal health information, PHI, which is highly controlled. Another, consumer health information. And then the other use case was genomic data, which leads us to this project. Real quickly, fast forward, Luna DNA has actually shut down. They didn't make it, or they went through multiple investment rounds, but at least that community data construct has not gained a lot of traction amongst consumers. So it's an interesting case study if you ever want to look at it. But again, there's many ways that genomic companies are interested in pulling data from people, having it shared, having it managed. And some of that relates to how the patient or individual actually controls and maintains some control of that data. So from this project, we published a few papers, including one that created the framework for what we're going to be talking about today. And we had multiple discussions with the Robert Wood Johnson Foundation at different blockchain conferences. This is when blockchain was really popular. And we finally, talked to them long enough to understand, let's conceptualize this idea of using blockchain for Indigenous data sovereignty. And we had the great partner of NBDC to kind of be our community, liaison for building a system that was meaningful and purposeful, and hopefully has some real world implications or impact. So as most of you know on this call, if you're a researcher, getting funding is a long haul, and this definitely was in our case. So, we had discussions with RWJF. We presented to them a number of times, and this project was funded 2 years ago, but really it started about 6 years ago with the idea itself. So the project team we have are people that I know that have already presented at AI Ready before. Kale Fox is one of the co-program directors for it. I'm the other co-program director. Kale comes, of course, from a very robust Indigenous health background. Myself, I'm more the technologist. I'm the person who has the more blockchain-based background. And in between, we have people that are focused on supercomputing. So we have engineers that are specific to blockchain and that run what we call the Block Lab here at UC San Diego in the San Diego supercomputer. Sorry. And then our support team, which is actually not our support team because they're doing so much great work on this project, our Sam Hurst, who I believe is on the call as well. She's doing a lot of our qualitative studies associated with this project that I'll talk about in just a second. And then Alec Kalak, who is a PhD student in the Joint Doctoral Program in Global Health and a leading scholar in Indigenous health. He's doing a lot of the work on this project as well, and a lot of the translation to those community values we talked about before. And then Tiana McMahon is our project manager. So a very diverse group of people, including Ken Miyachi, who is our blockchain engineer, actually comes from the blockchain space and currently works for a blockchain company right now as well. I think we have a little bit of background noise. There we go. Okay, cool. So just to overview what the aims of the project are. The primary objective is to enable a distributed community-mediated management of Indigenous genomic data. And also understand how that environment can be useful for other researchers, biotech companies, and other individuals that may want to participate in this network, but in a privacy-preserving manner. So all of that is hard to get to, but we're trying to build a prototype that can do some of those things among different use cases. And, oh, sorry. So for aim one, before we even start building something, we wanted to conceptualize it in the context of what the community wanted. So we did a number of consultations with NBDC and with the broader Indigenous academic community to understand what the parameters of a blockchain for Indigenous data sovereignty would look like. So again, before even developing something, understanding again what some of the core values are that need to go into a system was the first step that we're continuing to do and is an iterative process. Aim two was to actually develop the proof of concept or the POC, actually the environment of the blockchain, which we have a few slides for as well, and try to build out some synthetic data sets that we could then test the system on and run certain processes with it. And so that's something that we're doing now as well. We're trying to identify those best use cases for this particular technology. And then aim three was something that I think will be harder to get to, but is to develop some sort of evaluation framework for how we can assess whether this technology is useful or not. And I think this is something that will actually be an evaluation framework that applies to multiple forms of technology, not just blockchain. So this is a project that is spinning out of this funded grant, but I think will have broader implications because it will look at multiple forms of technology, not just blockchain and not just genomics. So for aim one, we wanted to formulate the core principles of a blockchain IDS framework. For those of you who are already IDS scholars out there, you know that there is a lot of literature on Indigenous data sovereignty. And what we were trying to do is translate some of those elements to technology features and specifically map it to a blockchain solution. So here are some key terms. I'm not going to, go over all of them, but these are some of the key terms that we live in the blockchain space. One of them is called a DAO, which is specific to a platform on blockchain called Ethereum, where it's essentially, like a digital community or digital board that can govern the blockchain environment. So that's something we're using in our particular development. Smart contracts are these self-executing contracts that can make processes faster. And there's a lot of nuance between where you store data on a blockchain, off-chain, and on-chain as well. And then there's other things like we did talk about cryptocurrency. Well, that is one application layer for a blockchain where we can actually reward people for certain types of actions on the blockchain. So those are some other things we're exploring when it comes to the issuance of tokens and how that impacts the governance of the system. And then, what is exact type of data are we storing on the chain versus off the chain? What can be fast queried by a researcher versus that private information that would reside off chain, for example? So all of you probably know a little bit about blockchain, but it's kind of in the name. But essentially, blockchain is a block of data that are connected through hashes and through cryptography. And from that, you get the kind of provenance of the data. So you can see what was the first part of that data, the first transaction, second transaction, third transaction, fourth transaction. And they're linked cryptographically so they can never be separated. So you get provenance to that data, and that data is also distributed across multiple ledgers that everyone can see. So you have one ground truth of data. Essentially, instead of having like one ledger that I try to decide who did a debit or credit against it, and then we're using an auditor to figure out between the two. This ledger is distributed by everybody. Everyone agrees through what's called consensus that this is the final ledger, and all the information is treated as a truth. So a lot of times people talk about blockchain in the context of a trust machine, making it more visible to everyone what the transactions were, seeing what the provenance was, so essentially the order, and then third, everyone agreeing that this is the final transaction. So that's one of the core principles of blockchain. But a lot of people, again, focus on the application layer, which is in the context of the cryptocurrency component, which essentially says this person owns that cryptocurrency. This is how it was spent over time. Those are the different transactions. And we all agree on it because we built consensus through some sort of consensus mechanism. So essentially, that is some of the reasons why we are looking at blockchain in the context of data governance. So some of the topics of exploration we were interested in, and this is kind of translated over from the IDS components, is data for whom? So who are we collecting data from? How is data collected? What's the classification of that data? And some of those technology principles could be things like digital identity or e-consent, which can also be built into a blockchain. Types and storage of data could be what type of data are we storing on a blockchain? Genomic data versus other data that may link a record to genomic data, such as certain behavioral-related data, or even PHI, for example. What type of, are we talking about the collection of data from an individual? Are we talking about collection of data from a community level? And we'll get into a little bit of that later on as well. So that implicates technology features like data management, digital wallets, and cloud computing as well. Use of data, what is the way that we interpret that data? What is the authority and management of data? How do we use it? How do we share it? How do we aggregate it? The benefits sharing component was something we talked about in the token space. So a lot of those areas can implicate other forms of technology, of course, like machine learning, smart contracts, and then the actual distributed applications that are running on the blockchain that people actually use and see. And then this other component of privacy and confidentiality. What are the expectations of individual versus community privacy? Who should be overseeing this type of system, such as a tribal IRB? And what is the role of culture in making these collective decisions? So again, these also implicate other forms of technology like on-chain and off-chain storage and dynamic consent mechanisms. So at the core kind of design phase, what you want to think about more private blockchains or business blockchains is that these blockchains allow for an immutable distributed ledger that can better ensure resilience, provenance, traceability, and management of data. And then what goes on top of that is an application layer that can be used for things where people actually interact with the blockchain. Generally speaking, when I teach this in my more business classes, so this is not related to this project, but when I teach it at the business school level, I'm really thinking about three primary design elements. Is it a private blockchain like an intranet where only certain users can access it? Is it a public blockchain that anyone can use? For example, Bitcoin, where anyone can buy a Bitcoin and it's not restricted to certain users? Or is it a hybrid model where some of it is public and some of it is private? And that's also what we call a consortium-based model, where you might have multiple individuals or organizations join the blockchain, even though their authority is essentially distributed. And that these particular design decisions should map to specific IDS values and community needs, like data sharing, how to manage that data between individuals and communities, how much authority is delegated, and the use of smart contracts, as we talked about before. So what does that actually do? Like, how does that enable IDS? Well, can it enhance data sharing? Can it improve health outcomes or access to health services? Can it enable better data robustness? And can it enable data sharing and community or individual ownership, meaning that does a system like this enable people to have more trust in the way that they share data or their communities share data? Those are some big questions we haven't really gotten to, but those are some of the core design questions we have when initially developing this idea and kind of scoping it out. So as a first kind of community exercise, we took this broad definition of blockchain and also what it can do in the context of IDS and we presented it at 3 different panels at the Ideas Summit at the Arizona State University. And this was a conference that was led also by NBDC and others. And we were looking at questions about, do people even want blockchain in the discussion of IDS? And so a lot of people that we talked to in these sessions were really not interested in blockchain. They could care less about blockchain. They just wanted to know what the feasibility and potential use cases were for a system that we were trying to develop. And there was a lot of concern about level of authority, and that includes within tribal villages and units. How much authority should be delegated to a tribal leader versus an individual? And there was also discussion about other indigenous communities outside of the US and how they were using blockchain in the context of energy or environmental issues that were separate from health. And again, this larger question of what data should actually be on the blockchain. So those are some, broad conceptual things that we had long discussions on over 3 sessions and that helped us kind of frame again a little bit more about what we were going to build later on in this project. And so I'm sorry if I'm talking a lot, but if you guys do have any questions or comments, feel free to put them in the chat, raise your hand. I'll stop at any time. So that was the first kind of community engagement we had. It was a really fascinating conference because there was a lot of discussion about other Indigenous health and Indigenous rights related issues, especially when it comes to data management. There's a great session on Indigenous rights in the context of legal systems and litigation. And so a lot of other people at the conference were interested in other use cases outside of healthcare as well. So another activity we did was we presented this at also the World Federation of Public Health Associations, what's called the WFPHA, at their World Congress on Public Health. So one of the things that the World Federation of Public Health represents is it is all of the different public health associations around the world. They come to this conference, they are part of this Congress, and they represent the unique perspectives of, public health professionals, across least developing countries, middle income countries, and also high income countries. So this was a venue where we thought that there was a lot more discussion about how this technology could, be used for other indigenous populations in other countries as well. So we had about 30 people in attendance. And one of the things I want to highlight is one of our speakers, Emma Rawson, is actually the incoming president for the World Congress on the World Federation of Public Health Associations. And she's the first Indigenous woman to lead the organization in its history. So a really good representation within the international community of Indigenous people's interests, because now she's leading this large public health organization. So a lot of the discussion here was focused on issues around digital health equity, population level research, practice and policy. So, a lot of discussion around applying the fair and care trust principles to this particular project, making sure that there was methods of accountability, and then linking also other tribal organizations within a consortium model. So these were some of the things we were talking about, like what does an actual consortium look like of multiple tribes that participate here, and how do we grade to the rules and governance framework? And then some discussion also in the context of, research translation, like how does this actually impact an Indigenous health scholar or researcher? So here's just a picture of the presentation we did. Alec was there as well. Some other quick things is we presented this at APHA, and I'm Japanese, so I go to Japan every year to lecture there. And even some of our colleagues in Japan at Osaka University were interested in this project, not from an Indigenous health standpoint, but from the context of how you use smart contracts to distribute personal health data. So we're getting a lot of other interests in this project outside of the Indigenous health space with just the traditional data management governance structure. So we also have a community advisory board associated with this project of people representing both NBDC and the Cheyenne River Nation. And so this is a very important component to bring these findings early to the CAB and make sure we're kind of on the same page, make sure that what we're building has some utility to the community itself, and also think of it from a business perspective, like what can this project actually become later on in the development cycle. And the other thing we've also done, which is a current project that's going on now, is we're doing key informant interviews that Sam Hurst is running for us, where she's talking to a number of different Indigenous groups and individuals to see what they think about the broader context of data sovereignty and then the application of technology to Indigenous data sovereignty. So this is a little bit broader than just blockchain and genomics, but it's meant to give us a guide for what decision makers, a lot of decision makers in Indigenous tribal units are thinking about when it comes to technology, privacy, and data sovereignty. So we're doing about 20 KIIs we're hoping to get done. And I think this will be a really good result out of this project in the broader context of how do we use technology to facilitate IDS. And if you have more questions about that, you can ask Sam because she is leading that component. So a lot of qualitative coding done, some transcription being done as well, and we're getting some synergy across these different KII respondents. This is actually a poster we'll be presenting on the project, the qualitative component, the KIIs, at the UC Global Health Day, which is a day that all the UCs come together and talk about global health. And you can see some of the main things we're seeing are things about sovereignty and tribal autonomy, data protections and control protocols, how do you build those, best practices in conducting research with tribal partners, that's very important, and building those best practices into this governance framework, incorporating certain values of tribal data management, including this idea of having data as a relation. And we have to build that narrative and understand how to tell that story in this particular solution as well. Something I've struggled with, but we have great partners to help us do that. And then navigating some simple questions about, is there actually an infrastructure to enable this technology? And how much of an impact does it have on the environment? So that's been a very important component of assessing whether technology should be implemented in these communities, is what's the overall environmental impact? And a lot of people have a perception that blockchain is very computational and heavy and intensive, but that really relates more to cryptocurrency mining. So that's another thing we have to evaluate in the overall solution, are these other value points that we have to look at. So I'm sorry, I noticed that we do have some comments. I haven't been looking at them, but I'll get through this last part and then we'll come back to those questions in just a second. Okay, so actually let's take a look at those questions now. One from Michael Schneider, is one major goal to share data across tribes? So Michael, that's a great question. Right now we're focused on partnering with NBDC, understanding what their kind of data construction looks like, understanding what the taxonomy looks like, and then using synthetic data to populate this blockchain so that it has some thin layer of genomic data that resides on the blockchain and some more robust information that resides off the blockchain. So what we call off-chain storage. And so a researcher would essentially be able to query some of that thin layer of data. And then if authorized, it could access the actual underlying genomic data. That would be primarily focused on data that is housed within NBDC's biobank, not the actual data, but synthetic data. And you could imagine that as different tribes join this consortium, and maybe these tribes already have data in NBDC or they don't, then they could agree to this governance framework and you could create a network of consortium, a consortium network of different tribal unions who share their data and benefit together with it. So that's the idea, but we're starting very small, just with the idea of backing in a blockchain into a native data biobank. What Indigenous data sovereignty use cases require a decentralized blockchain-based system? Where would centralized bank-like ledger systems fail in this context? So we'll talk a little bit about that, Millen. That's a great question, very nuanced question. What we're thinking about is some sort of distributed governance system where there is some centralization. In fact, I would argue that when you talk about private blockchains and business blockchains, they're not completely decentralized, and very different than a public blockchain that relies on something like a proof of work type of consensus mechanism where it's computational intensive, but it's much more distributed when it comes to decision making. So there is a lot of centralization. In fact, one of the organizations or governance structures in this project is the DAO, the Decentralized Autonomous Organization, in the Ethereum framework, and it is led by BDC and a number of other nodes that essentially comprise that DAO. So how you would structure that DAO that makes sure it has representation from different tribal units that have data in it are bigger questions that we have to ask. But essentially, it's kind of a hybrid decentralized versus centralized system where there's more people involved, but it's not completely decentralized where everyone has the same, read, write access or voting privileges, et cetera. I'll get into that a little bit more, how we're thinking about doing community-based proportional voting shares based upon the number of stake you have in the data, but that's an idea that we're also thinking of. And then Julie says, given the immutability of the ledger, how do you manage participants' rights, right to withdraw from research? So a lot of what we're doing on this blockchain is essentially just creating a log. It's just creating a log of whether a request was made for certain forms of data and how that access was adjudicated, how it was approved or not approved. So it's essentially not essential. It's not really, it's not going to be like a IRB process on this blockchain. That would be a completely different project. And it would be really focused on just IRB protocols that are written to a blockchain. In this context, we're looking at a log that says that someone requested access to data, and this is how that was adjudicated. So if someone wanted to not have their data as part of the NBDC biobank, that would happen off-chain, different from the structure that we're looking at now. And then Alvin, I think, has his hands up.
Hi, Tim. My name's Alvin from Johns Hopkins. Thank you for your talk. Fascinating. I have two questions. So the first question is, a lot of the design and principles you explained are very good, just data management practices. Are there specific things that you are doing in this proposal or blockchain architecture that are designed specifically to handle indigenous data versus if you were handling non-indigenous data, you would not have that component in it? And the second question is, if you take a step back at 30,000 feet, I assume there are other similar initiatives out there when it comes to blockchain technology and healthcare data. Where do you think what you are doing here fits in that universe?
Great questions. I will get through the next section, which will illustrate some of those issues and then answer some of those questions. But as a short answer, one of the things we're trying to do in the smart contract construction is to embed some of the requirements of a tribal IRB into that smart contract language. So it would maybe call on a smart contract that executes per the terms of the IRB process. And it may be something as simple as adding a node to the blockchain. And what I mean is if it's a consortium blockchain and we want to say we want to add this researcher to the blockchain, then we call in a smart contract to ensure that that researcher has gone through the tribal IRB approval process, for example. So it's not necessarily specific to indigenous data, but it's more specific to an indigenous data process or a governance process. And the DAO would then decide what that process would look like. So we'd have community agreement upon how that process is built, who votes on it, and then how it is adjudicated. When it comes to the actual data taxonomy of the data, there may be rules that we want to build in when it comes to metadata versus, snippets of data on genomic data and what is shared on the blockchain versus what's off-chain. So those are some things we kind of haven't really figured out yet, unfortunately, but there are plans that we want to do to customize it more to IDS. And then from a 30,000 feet perspective, I do teach a lot on blockchain use cases in healthcare. I came from a supply chain background. So most of the action in the early blockchain days was about pharmaceutical supply chain management with a blockchain. And some of those ideas also had elements of consortium blockchains. So essentially you would have a number of different pharmaceutical companies join a consortium. They'd have access to information about supply chain, and they'd be able to dictate things like shortages or fake drugs, things like that. Those use cases haven't been very successful in the healthcare space. I would say the most successful use case in healthcare has primarily been physician credentialing. That's a strong one where essentially you just make the credentialing process for clinicians faster by verifying records in a central authority. So essentially you have like a clearinghouse model, and blockchain's been used to authenticate records, for example. So unfortunately, in the healthcare space, we haven't seen a lot of strong use cases actually get into production. And that's one of the weaknesses of a lot of blockchain applications in healthcare. Joe has his hand up, and then we'll keep going through the slides.
Yeah, I mean, a little bit to Alvin's question. We're going to try to, with Dr. Mackey's help, merge lots of different concepts, and one of them is to get away from the cloud. A lot of tribal nations don't trust the cloud, and there was an article that came out a couple of weeks ago that even
And then we can sort of figure out where things are with.
oh, what's that?
I want to know where everything is first. I think that's the
Megan, you're unmuted.
Yeah, there we go. Go ahead, Joe.
Yeah, so a lot of tribes don't cloud, and so we're going to try to use the blockchain in conjunction with some of these decentralized Dockerized container solutions. Again, and not only for data security and more so for data implementation. So the kind of the lie between altruistic research and actual development of implementation is that research is funded highly to collect data, but in terms of health delivery, the United States and Congress often have tribal IHS systems and other healthcare systems at a minimum budget, and the budget is discretionary. So if the United States doesn't pay for that healthcare implementation, nobody else is going to. So we're trying to use the whole data sequestration as leverage, because tribes are sovereign, but they're also domestic dependent nations. The people are U.S. citizens, but they're also a unique data set, and they're a small data set. So the biostatistics has not been created for them, and nobody's going to do it unless we do it. So that's a big impediment to sharing data with other people, because it's meaningless. So we are trying to share data with other tribes, because it's comparing apples to apples instead of apples to oranges. But we hope that by creating systems like this, that it will be beneficial to other marginalized groups, whether they're African American or they're people like the Amish. That it will be useful to these groups that have very desirable data but no way of implementing it because they're such a small population.
Yeah, great comments, Joe. Thanks for providing more contextualization. And also, there's a question of how this type of governance structure would be implemented when it comes to actual technology infrastructure, like essentially distributed computers or cloud or things like that. So those are open questions, I think. And these decentralized containers was something we talked about as well. That could be a really interesting project. I'll kind of continue a little bit more with the prototyping phase that we're in right now. Just want to let people know that there is a paper on this that was published in Cell that me, Joe, Alec, and Kale published earlier last year. I think it was last year, or it was the year before. And it's the basic structure for what we're doing. So it's a consortium blockchain, you can see, where you could have tribal organizations or representatives. You could also have individual tribal members as consortium members. And then you could have non-tribal entities seeking to access that data. And so they would interact through a UI UX system on a digital app. A distributed app. And from there, you would have different forms of community consensus approaches. So you'd have smart contracts, distributed applications, and then things that talk about data permission. On the blockchain itself, you would store certain metadata, but it would be de-identified to the actual individual user. Now, I know genomics data is hard to really de-identify, but let's say we only include snippets of data or certain metadata associated with the user that are not identifiable or not easily reversible. From there, the blockchain hash is really just about recording that a data request was made for this data that was searched here using metadata. The authority nodes in the consortium would then vote on whether that person should get access to that data. And then the data is then queried off-chain. So you get a message saying, yes, you are allowed to access this data. And it gives you an address to get that data off-chain on NBDC servers. So this was essentially the first iteration of this idea. Very simple design, consortium blockchain with different layers of smart contract, distributed applications, and data permissions structured in different ways, depending on who you are in the consortium, which data stays on chain, and what the blockchain actually records, which is essentially just someone requested access to data, it was approved or denied, and then there's a discussion about where to gain access to that data. And then at the same time, you could have a smart contract execute so that the person who accesses that data is subject to tribal IRB regulations and anything else that may be specific to the access and use of that data, including potentially things like intellectual property and tech transfer. That could be another thing that could be built in. And then the actual access to the data is actually handled completely off-chain. So again, this is in Cell if you want to read it. It's relatively easy to understand. And one of the things we focused on here were these ideas like community consensus, where essentially what that would mean is that you could apportion tokens to people based upon the amount of data that they've contributed to the network. And anytime their data is requested, they would have a vote in whether that data should be accessed or not. And so what it means is that you'd have proportional voting based upon the data ownership, or you could structure at the tribal unit level, all types of customizations you could do that we, again, have not figured out, but is customizable in the system. So as a quick kind of background, we chose Ethereum primarily because of this distributed autonomous organization and the fact that it's a relatively ready-to-go enterprise blockchain solution. It also uses Solidity code for development, which is generally an accessible code base, and it's got a very, very big community of developers. And so the DAO essentially allows us to have community-driven decisions depending on how we structure the DAO. So it's like a board, it's like a virtual board, and all of the decisions made by the DAO are going to be made in a transparent way. And we have Aragon, which is chosen as the DAO provider, and as actually is what we use for the interface of the actual solution. And then we have different roles. So people in the consortium, different nodes on the blockchain have different roles. Some of them are owners of data. Some of them are storage providers. Some of them are people that could access and utilize the data. So we set up different role-based structures. And then again, what we're focused on are these issues of whether there's fair use of the data across the system and there's transparency to the decision-making process. So consortium blockchain, application layer is the DAO, which essentially makes decisions for the blockchain environment. The smart contracts execute the different processes on the blockchain, and then storage occurs both on-chain and off-chain. And the off-chain data is really the native data by BIG, NBDC. So some of the things that the DAO does is it can set rules. So it can determine who votes, which consortium members vote on which processes. So that's what the DAO can decide from a broader governance standpoint. So if we want to approve a research project on this NBDC IDS system, who makes the decisions about approving those projects? Who decides which entities can store data on the blockchain? That could be additional data that's stored, not the underlying genomic data. What is the retrieval permissions? Who can access that data? What is the compensation component? So RWJF doesn't want us to talk about compensation too much because it implicates a lot of tax issues. And that's not the remit of this project. But without some sort of compensatory system in place where an individual tribal member or even a tribal unit or something broader, the governance framework itself, benefits from allowing access to this finite data resource, there's really no economic incentive to build the system. So there are ways that we can attribute, for example, tokens to an individual based upon the usage of their data, and that could be set up in a way where a requester has to pay a certain value when it comes to accessing that data. That could be something as simple as something called Ether, which is the currency that's used for Ethereum, where they would pay that in exchange for participating on the blockchain. And that would be then redistributed to the members whose data were accessed, for example. Those are all things we can think about, we haven't decided on, but it can be built into the system when it comes to an incentive structure. And then again, maybe the DAO also decides how those resources are distributed to the different communities that share the data. Execution control, so we want to manage that access and authorization so that when you look at the blockchain, there's a very clear understanding of who requested data, how it was voted on, and whether that access was granted or not. Audit trails, that's one of the key components of business blockchains, is you create a immutable audit trail that can't be changed in any way. And then, what type of metadata are you actually storing on the blockchain so that there is some utility to it without, giving all that information out to other people. So we can configure for a lot of different things. This is part of our UI. We have an approval threshold, minimum participation. We can set a process for a minimum period. We can allow for early execution if it hits that threshold. And we can also allow for some proportion of which token holders are allowed to vote on it. So let's say you are, if you are a researcher, you don't get a token. You can make a request, but if you're a tribal individual, you get one token. And then if you're a tribal elder or something like that, maybe we apportion more tokens because that person's been delegated to by their tribal community members. So certain groups of people could vote on certain processes based upon their token allocation. Or again, we could structure it so that people's data who's accessed have the most proportional share in that voting. So see, these are some of the criteria we can customize for different processes. And the customization doesn't have to be specific to all processes. It can be different for each process. So for example, a DAO member creates a proposal for a research project. Upon that proposal being adjudicated, it adds a storage provider so that data can be stored on the blockchain somewhere. And then we record that voting process to approve that research project, for example. So here again, here are some of the voting constructs here and what it looks like in the UI UX. So essentially, this is the options you have to vote yes, no, or abstain. This is how many votes you get per token, the minimum criteria. And then we ran this process to show that it was published, running, succeeded, and executed. So a very crude UI UX version of a process that doesn't exist, but shows the feature set that we can build. And again, we can add a new storage provider. We can add another wallet address example, and you can deposit things in that wallet like data sets and also things like tokens as well. We also have a video which shows a split screen of essentially how this process works. It shows how genomic data is requested, but that request is not authorized and how it's denied. For example, it shows how the voting from the DAO members are authorizing a particular user. And we have a link to that video if you want to take a look at it. It's narrated by our blockchain engineer, Ken Miyachi. And if you're curious about how it looks from the code base standpoint, all the way to what it looks like on the UI UX, you can view that, again, very at the prototype stage, but we are building something currently and trying to iterate with that with very specific use cases with NBDC. So the next steps for us are really to work collaboratively on the governance process with NBDC. A lot of people get interested in this project, but the reality is we're primarily building it for the benefit of NBDC. They're our community partner. They're who we're working with. And if other consortium members would want to join, or NBDC wants to create this under a consortium umbrella, I think that's under their decision-making process to expand this if they want to. This is really a project focused on linking it up to NBDC values. We do need to generate that synthetic data set or ontology. Yes, and we can give you the link to the video as well. I'll make sure to send that to everyone, or I'll send it to Brittany after the call to make sure everyone has access to it. So we need to generate that synthetic data set. We don't need access to the real genomic data. We need to build some use cases that actually show that certain parts of the data can be accessed on-chain, off-chain, et cetera. The other thing that we've learned, especially myself, is we need to tell a story. We need to tell a story of what this environment looks like. How is this environment representing data as a relation? Is this blockchain architecture? Is it a community? And does it lead to more accountability across these different community members because we have a system in place where people can be actively participating on how their data is used as part of their relation? So I'm not very specific on the terminology, but we're working with a lot of Indigenous scholars to frame this as a story, as a narrative, so it's better understood and the value proposition is more clear. And then, of course, we'll be drafting manuscripts associated with this project as well. Alec Kalak, our PhD student, is also working on a evaluation framework, as I mentioned before, based upon an existing evaluation framework for Indigenous data sovereignty. And we're doing a systematic review looking at the literature associated with both IDS and also technology. Not a big surprise, there's not that much literature out there. So we should be having one of the first systematic reviews looking specifically at IDS and more specifically at how it links up to technology. Let's see, I think that's it. The only last thing I would say is we are attending the conference at University of Arizona. It's a U.S. Indigenous Data Sovereignty and Governance Conference or Summit. Joe will be there. Joe and NBDC are very active in this conference. So we'll be presenting something similar to what we've done here with a little bit more interaction on the prototype stuff. And we also hope to have that narrative built so that people can understand the technology, not just from a technical standpoint, but for what possibilities there are to implement it in communities. And then one of the things that we're seeing now is that there could be some application of this technology to other communities of interest, not just Indigenous communities, but also other distinct communities that want to build consortiums or essentially want to pull data together and also benefit from that data together. So the underlying principle here for genomic data is the more genomic data, the better, the bigger the biobank, the better. And if people can coordinate in these consortiums to share data and gain benefit from it and have some shared decision-making process, then perhaps there's a win-win for these consortium members. And that's it from my side. I know we have about 7 more minutes, and I know we have a few questions here. I see one, I'll just pick up from Jack that says, you have a sense of a time frame for when this endeavor will yield an educational lecture showcasing a streamlined platform that serves as a hub, submit data requests, track BIDS, registry, etc. Yeah, I think we don't know. I think it's probably a year away or so, but we really have to build that first use case. So a simple use case might be, this is a consortium blockchain run by NBDC. Who gets to join this consortium? And how do we vote on that process? And how do we make it transparent? And when you vote, do you get a certain amount of tokens, for example? And that token represents your proportional voting share on the blockchain. A very simple process around that may be the first thing we do. And then the second thing we do is maybe, how do we build an environment where an Indigenous scholar can submit a research project idea and the community can vote on it and perhaps even provide some of those tokens as support or resources to actually run that project. That could be another use case we build on this blockchain. So we really have to identify that use case first with NBDC and start a development from there. And then again, like you said, build it in a way that is educational, technical, and also, I'm not sure implementable is the right approach. This project has a limited scope, where I think we can build a prototype, put it out on GitHub, provide documentation, hopefully build a few good use cases, 3 or so, and then hopefully let the community build on it from there. But one of the things we have heard is there are not a lot of blockchain engineers. There's not a lot of capacity here. So that may also be, something we have to deal with as well. Camille, I think you have your hand up.
Yeah, Tim, thank you so much. This is really just
Nice to see you.
Nice to see you too. I was just thinking as you were describing this, it just seems to me like it is setting a best practice or an ideal approach to large data management. And I think about like with what we're doing with AI Ready and building data repository. Is this model that you're creating something that could be emulated, picked up? I mean, it seems like you have all the pieces that it could be replicated. Is that true?
Yeah, I think that there's a lot of use cases here. For example, I didn't talk much about ethics in this discussion, which could be a whole other kind of application layer for this. So you can imagine a DAO that is structured in a way to deal with just the ethics and IRB requirements for this data environment, for example. And so you could construct that, and then there would be a token allocation based upon, for example, whose data is accessible or not. And then those IRB processes could be more dynamic, for example. And then they'd be recorded and immutable in a way that the whole community could see it. So that transparency element could be very interesting as well. So there are ways to kind of customize this to, other examples. And again, what we talked about, which would be great to get your feedback on, is, when you have those smart contracts that you're building, you're automatically executing them per some sort of IRB requirement, for example. And so that could be very interesting on how you build that in, and hopefully the process is maybe a little faster that way.
I was thinking pretty much everything you were talking about has ethical and social implications. You were talking about data management, governance, consent, continuous consent, transparency, community engagement. All of those things for me are ethical constructs of how you do this well. So I just really appreciate everything that you've done, and I'll pass it over to Joe.
Thanks, Camille.
Yeah.
Appreciate
Yeah,
it.
and I wanted to point out to my earlier comments. So tribes, like I said, they're not necessarily part of the United States. So for some tribes, like Alaska Native tribes, they function as corporations, and so there is this sort of disconnect between their ability to share in the benefits of this kind of research because of that division. So there is this necessity to try and create a hybrid solution of data sharing that is more like sharing data with Monsanto or sharing data with Google or something like that. And I know for a fact that the NIH, when they're working with Alaska tribes, they're a lot more afraid of Alaska tribes because Alaska tribes function under corporate law. They don't function in under treaty law. So there's that. And then also I wanted to say that IRBs have not kept up. The Common Rule, the Belmont Report, has not kept up with this new data landscape. The data is being collected in large amounts very quickly. It is exposing lots of different risks, not the old Common Rule risks that we're all accustomed to, but new risks in terms of surveillance and the ability to put people in jail and all kinds of things, the ability to exploit data and profit from it, all of those kinds of things. So I just wanted to say that tribes aren't going to function on an IRB system. They're going to function on legislation, tribal legislation that regulates research and regulates data. So it's inaccurate to say an IRB is going to make this decision. IRBs don't really have any power, but tribal governments do.
Yeah, and I think that the way that you structure the node authorities is, certain tribal organizations or authorities would have ultimate decision making in a centralized DAO. So I guess, it's a minor thing to talk about, but blockchains are considered completely distributed. This is not a completely distributed system. There is an authority structure, and that authority structure would then vote on these processes, but it would be in a transparent way. The thing we haven't even figured out is what, if any, is the role of an individual tribal member? And do they want a role at all? Or do they just delegate their authority to their tribal elder or tribal authority, and their stake in their data is delegated that way? We have not thought about that. It may be different for each tribe. It may be different for each process. We have no idea. We're really at the very basic principles of this architecture right now.
Yeah, for instance, data about missing and murdered Indigenous women has to be shared widely, and if we're going to find those women, right, or at least find their bodies. Same thing with environmental pollution. There's a lot of racist environmental pollution on reservations where either the Army or some other corporation dumps chemicals onto the reservation. So that data needs to be shared too, but just has to be shared in a manner that doesn't hurt the tribe and helps the tribe win court cases.
Yeah, and then just coming from the kind of pharmacy industry side, one of the main use cases here is if a pharmaceutical company wanted to do some sort of drug discovery or use genomic data, what is the appropriate relationship it has in this kind of ecosystem? And those are thornier conversations to have, but I think we can explore those issues, at least with these use cases. Maybe one of the use cases we'll focus on is a non-tribal affiliated group that wants to gain access to this data in order to do drug discovery. And maybe the IP or tech transfer provisions are completely different. They're based on different smart contract rules, and there's some proportional benefit sharing, either through tokens or some other compensatory mechanism that we can explore here. So those are some of the things I think that we can do in a phase 2, phase 3, but we really have to identify maybe one or two very practical use cases at the beginning.
Well, thank you again, Tim, for joining us. We really appreciate the work you're doing, and look forward to learning more from you. I'm going to turn it back over to you, Brittany.
All right, thanks everyone. We will share the recording per usual on our AI Ready website. So look forward to that in the next couple of weeks or so. And please complete the eval. Take care, everyone.
Feel better, Joe. See you guys. Thank you.